This video shows one way for students to summarize the big unit concepts into a checklist of generalizable ideas to later help them write evidence-based explanations. Task talk and tools play critical roles throughout this lesson. As you watch, observe what kinds of tasks students are engaged in to make their thinking visible. What tools help students communicate their ideas? And how do particular talk moves facilitate students' summary of explanatory ideas? In this unit, students are learning about the energy transformations that occur in circuits and are reasoning about why a flashlight would stop working after being left on for 30 days. This unit had a big idea about energy transformations. As students are engaged in multiple activities over the course of the unit, the teacher asks the students to compare activities and find similarities. This makes students go beyond merely retelling what they did and moves them into thinking about the bigger picture concepts that link activities together. In this next clip, note how the teacher references a prior activity and sets up today's task of comparing different types of circuits.
Everyone had different circuits, like one group had the lemon clock circuit, one group had a solar panel that they powered with the overhead light because the sun wasn't bright enough.
And one group had a balloon.
One group had the totally new kit, which I think they've made the spinny thing that flew off in the air with the motor that would release it. This group had that same thing, and they flung the disc into the corner and they had to go get it. And then the group over here, 4 people with no screwdrivers, really worked hard to make their crank light work. So we all had things that had circuits.
I didn't.
Well, but Kate helped us out on that one. So we all had things that had circuits. So I'm interested in, what are some similar ideas? This is kind of a tricky question, so listen carefully. With all these different circuits, the lemon clock, the battery-powered motor spinny thing, I don't know what the technical name is, right? The dynalite, where you used your arm muscles. The spinning thing? Yeah, sounds good. Technical, right? Yes. So with all these different circuits, the solar panel, that wasn't powered by a battery, that was powered by a light. But all of these different circuits, what are some similar things that are happening in each of these circuits? It's a tricky question. Take a minute to think about it.
I got sweets.
And maybe try to think of more than one thing they have in common. Turn and talk. What similarities are between all of these circuits that we've been talking about? What's something that's the same?
Energy in them. And they're all powered by energy. There's something that all of them have like control, like like let's say there's like a button or a panel. They all have like something controlling it. Yeah, energy makes it right. And then
We're making a dramatic moment here.
all are a circuit.
We did.
All can function
Share with me. What do you think?
They both have circuits. If both have like put
What do both of them do to the energy?
They all do.
Where is it?
They use the energy to make sound waves.
After talking with a partner and making their own list, students shared out to the class what similarities they discussed. The next clip illustrates how the first bullet, circuits transform energy for a certain reason or purpose, was co-constructed in a whole class effort. Notice how the teacher asks for students to agree on wording before writing on the checklist. Also note what talk moves the teacher makes to connect students' ideas.
I popped in on some really good conversations about identifying some really general similarities. Like you guys didn't get stuck on the specifics of like, well, that one had a lemon, and that one had a battery, and that one had a solar panel. But what's the similarity between the lemon and the battery and the solar panel? You guys really focus on some general things. So let's start on, we're going to make our list of ideas, and you can just write it under your question. I had this extra bullet because I think the ideas we're about to discuss will be really helpful if we have to explain a circuit in the future. So I'm just going to make a list here. You can make your list in your notebook. And I call this list the gotta have checklist because it's kind of the general, like if you're going to talk about circuits, you gotta have certain ideas that you're talking about. Even if you're gonna explain the lemon clock, or the spinny, technical name, spinny spoopy thing, or the dynamo crank flashlight, they all have the ideas we're about to share. Okay, Sarah, do you have something to share? They all use energy. They all use energy or make energy. Okay. Energy is involved. Is that what you said?
Yeah.
Energy is involved in all of them. How is the energy used, or you said maybe made, or evolved? What's happening? So we have this energy idea. So what's happening with the energy in our circuit? That's going to be maybe a first class. People adding on to this energy use, making, even. They all have electrons and atoms. So that's talking about the matter. That's the stuff. So we'll have that as a second thing too. So I'm going to hold that for a second. Let's finish this energy idea. Do you have an energy idea about energy? Emma? About energy? Okay, let's stay on the energy thing for a second. Yes?
They all have... Wait. They
Yeah.
all transform it.
Sarah, do you agree with what Emma just said? Because I was thinking, and then Colin too.
That's sort of the reason they're there, to transform energy. Like, what's the point of having a light? Like a light that needs the sun to power a flashlight. I mean, like, that doesn't store energy. But if it's a fan, then you could be hot.
They transform energy, and maybe that's for a specific purpose. Would that be good to add? For a specific purpose, or just?
I heard, a couple people saying that they all do something, right? They have some kind of
Should I say specific purpose, or a certain job, or function? What kind of wording do you want here? Function, for a certain reason or function. I like having synonyms because that way if we forget what one word means, we have the other word as kind of a backup. Or function. I know function comes up a lot in science though, so I do like to have that word up there too.
Ideally, students help to create and add to this checklist over the course of the unit, adding important ideas over time. However, in this circuits unit, students helped create this checklist towards the end of the unit as a pre-writing task. This checklist becomes a writing tool for students to use when they write their explanations to answer the unit question, what causes a flashlight to stop working after being left on for 30 days? Students use the checklist to explain a circuit they made as part of their unit assessment as well. They used circuit kits and had to explain the function of the circuit and how and why the circuit worked using ideas from the checklist and evidence they collected during the unit. Let's revisit the tips about the kind of talk, tasks, and tools that help students summarize key unit ideas. When planning the unit, the teacher identifies key ideas that students must understand in order to explain a particular science phenomenon. Each activity provides students with evidence for a piece of the overall scientific explanation. In order to make a gotta-have checklist, students must identify similar ideas that hold true across activities or models. These become generalizable gotta-have ideas when explaining the phenomenon. Use talk moves to orchestrate a whole class conversation to add to or change items on the checklist. Remember to use student language alongside science terms, so it's a useful tool for students later on when they use this checklist to write evidence-based explanations about the science phenomenon. Ideally, add and change items on the checklist over the course of the unit so students can see that they can change ideas over time based on new evidence. In this case, however, it worked well as a pre-writing activity. According to the Next Generation Science Standards list of science practices, students in grades 3 through 5 should combine information from multiple sources and use it to construct or support parts of an explanation. These are key parts of creating and adding to a gotta-have explanation checklist. Additionally, this unit addresses the energy strand found in the Next Generation Science Content Standards. For more information about this or other science teaching practices, please visit our website at toolsforteachingscience.org.